Today's problem is sentence similarity. Take a moment to think about it. How would you determine if two sentences are similar based on a list of similar word pairs? What would you do? The problem asks us to determine if two sentences are similar. The input consists of two arrays of words, representing the two sentences, and a 2D array of word pairs that are known to be similar. The output is a Boolean indicating whether the two sentences are similar. To understand this, let's consider an example. Suppose we have two sentences, great acting skills and fine drama talent. We also have a list of similar word pairs. Great is similar to fine, acting is similar to drama, and skills is similar to talent. In this case, we would say that the two sentences are similar because each word in the first sentence has a similar word in the second sentence. Now, let's consider another example where the sentences are great acting skills and fine drama. In this case, the sentences are not similar because they have different lengths. The problem statement also mentions that the input sentences will have the same length. This constraint is important because it means we can compare the words at the same position in the two sentences. The obvious thing to try is to compare each word in the first sentence with each word in the second sentence and check if they are similar. We can do this by creating a set of similar word pairs and then iterating through the words in the sentences. For each pair of words, we check if they are similar by looking them up in the set. If we find a pair of words that are not similar, we can immediately return false. If we get through all the words and haven't returned false, we can return true. Let's walk through an example to see how this works. Suppose we have the sentences great acting skills and fine drama talent, and the similar word pairs great is similar to fine, acting is similar to drama, and skills is similar to talent. We start by comparing the first words, great and fine. We look up great and fine in the set of similar word pairs and find that they are similar. Then, we compare the second words, acting and drama. Again, we find that they are similar. Finally, we compare the third words, skills and talent. Once again, we find that they are similar. Since we've compared all the words and found that they are all similar, we return true. This approach works, but it's not very efficient. The problem is that we're doing a lot of repeated work for each pair of words. We're looking them up in the set of similar word pairs. This results in a time complexity of O(n plus m), where n is the length of the sentences and m is the number of similar word pairs. The key insight here is that we can use a HashMap to store the similar word pairs. This allows us to look up the similar words for each word in constant time, rather than having to iterate through the entire list of similar word pairs. To understand how this works, imagine you have a dictionary where each word is a key and the value is a list of words that are similar to it. When we encounter a word, we can look it up in the dictionary and immediately find all the words that are similar to it. We declare a dictionary to store the similar word pairs. Then we iterate through the similar word pairs and add each pair to the dictionary. For each word, we check if it's already in the dictionary. If it's not, we add it and create a new list of similar words. Then we add the other word in the pair to the list of similar words. Once we've populated the dictionary, we can use it to compare the words in the sentences. For each pair of words, we look up the first word in the dictionary and check if the second word is in the list of similar words. If it is, we continue to the next pair of words. If it's not, we can immediately return false. If we get through all the words and haven't returned false, we can return true. Let's trace through the optimized algorithm on the example input. We start by declaring a dictionary to store the similar word pairs. At this point, the dictionary is empty. Then we iterate through the similar word pairs. The first pair is great and fine. We look up great in the dictionary and find that it's not there, so we add it and create a new list of similar words. The list of similar words for great is currently empty. Then, we add fine to the list of similar words for great. Next, we look up fine in the dictionary and find that it's not there, so we add it and create a new list of similar words. The list of similar words for fine is currently empty. Then, we add great to the list of similar words for fine. We continue this process for the remaining similar word pairs. Once we've populated the dictionary, we can use it to compare the words in the sentences. The first pair of words is great and fine. We look up great in the dictionary and find that fine is in the list of similar words, so we continue to the next pair of words. The next pair of words is acting and drama. We look up acting in the dictionary and find that drama is in the list of similar words, so we continue to the next pair of words. The final pair of words is skills and talent. We look up skills in the dictionary and find that talent is in the list of similar words. Since we've compared all the words and found that they are all similar, we return true. You'll spot this pattern when you see a problem that involves comparing pairs of items and checking for similarity, or when you need to efficiently look up items in a large list. The time complexity of the solution is O(n plus m), where n is the length of the sentences and m is the number of similar word pairs. The space complexity is O(m), where m is the number of similar word pairs. Try the next problem, it uses a similar pattern. Subscribe and ask me any questions you have.